Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on word search. So the problem states that we are given a 2D board of characters and a word. We need to return true if this word exists in the given grid. So the rules are you can move in any direction except diagonal like up, down, left and right. You cannot reuse the same cell and the letters must be connected sequentially in any direction. So the intuition is we must try every cell as a starting point. We must explore all the directions and we must backtrack if the path fails. So at every step we will check the bounds. We will check if the character matches. We will check or we will mark if any particular cell is visited because we cannot reuse the same cell. We will explore the neighboring cells and we will undo the visit or we will just backtrack. So the brute force would not work because we have to try all the paths from all the cells, which is exponential. But the optimal approach for this is only backtracking. I think this is too much. For now, let's move on to the code. So, yes. What do we need? We need the rows and columns. So for that, rows would be board.length and columns would be board of 0 dot length. Right, now we will try starting DFS from every cell. So for that, for row 0, row less than the total number of rows, row plus plus, and we will also iterate through columns. From column starts from 0, column less than columns and column plus plus. So yeah, now if the DFS finds the word, then we will return true. Otherwise at the end we would conclude that the word is not found anywhere, so we will return false. So for that, let's implement a method called DFS. For now, let's call it. We will pass the board, we will pass the word, and we will also pass row and column, and we also need to pass the index. For now it's 0. Okay, if this is true, then we will return true. Okay, otherwise at the end we will return false, saying that the word is not found. Now let's implement that DFS, and the return type would be boolean because we are checking for it. So boolean DFS, what did we pass? We passed board, okay, then we passed word and we passed RNC and we also passed index. Now if all the characters matched, that means that is a good sign. So we will check if the index reached the end of the word's length, which means it matched all the characters, and we will return true. Okay, otherwise we need to check the boundaries. So which means if R is less than 0 or C goes below 0, or what else do we have for the boundaries? If we check the lesser part, now we need to check the greater part. If R is greater than or equals to board dot length, or if C is greater than or equals to board of 0 dot length. Okay, we checked 4 directions. So we will return false. Okay, so this is boundary check. Then we will check if any of the characters mismatch. So we will check if board of row of column is not equals to word dot character at the given index, then we will return false. This is nothing but a character check. Okay, now after checking these, and if it passed these conditions, then we need to mark the cell as visited in order to reuse the same cell. So let's take a temporary character called board of R of C, and let's mark it as maybe hash to indicate that we have already visited. Marked as visited. Okay, these 2 steps are for that. Then now we have marked the cell as visited, we checked all the boundary conditions, and we checked if the character matched. If all these passed, then we will explore all the 4 directions which are allowed. So boolean found is equals to we will call DFS of, what did we pass? We passed board, word, what did we pass? Row, column and index. So now I'm writing it for down direction. Down means row plus 1 and the same column, and we will pass the next index, or wait, okay, so this is for down, and this direction is for up. For up, the row should decrease in the same column, so this is for up. And next, right. For right, it will be the same row, but it will move to the next column to move right. So this would be for right, and for left it would be in the same row, but it would move to the previous column. So column minus 1, and this is for left. So now we have explored all the 4 possible directions, and if any of these is true, that's why we used OR condition. If any of these is true, then we will say that the word is found, and we will backtrack to the original board of R of C is equals to 10. Initially we stored the value of this in a temporary variable because we don't know the exact character that is present in that particular cell. So we stored it in temp. Now we are putting the exact value which is already stored in the temp back to the same cell. This is for backtracking or undoing, I would say. Then we will return whatever is present in found. If all of them are false, then found will have false and we will return false. If any of them is true, then we will return true. So yeah, let's run the code. Okay. Word dot length, okay, it's string. It's accepted. Let me submit it. Okay, it is accepted. So okay, to dry run, if you consider an example, let's say this is too big to take it as an example. Okay, let's take this. Okay, so we will start from each S. Okay, so we will start for each S. We will explore the neighbors and we will backtrack if it is a dead end. So we are looking for word ABCB, but ABCB is nowhere, so it is not possible. That is why it is false. For this, what about this? SEE. Okay, so we will start exploring from A. We will check in all the directions. No. I mean, this fails in this line itself because the character itself is not matching. So it might explore for this S, but if you move in any of the directions, the second word is not E, so it will move only in this place when it explored the direction down, and from there when it explored the left, then only it will match, and when it reached the word length we will return true. So yeah, that is it for today's problem, and I will see you in the next one.